I will be concentrating more on pneumatic power systems, which comes under the module 4. So this will be my first session. Out of different types of power systems, as we know, the hydraulic power systems, pneumatic power systems and electric power systems, starting from industry to the minute robotic applications, all these three types of power systems have been extensively used, out of which hydraulics power system is the one which takes a more load compared to the other two power systems, and electric power system is the one which takes electrical energy to transmit the power. When it comes to the pneumatic power systems, a air or a gaseous fluid which has been used as a power transmitter. Now here a fluid is a one common terminology that we use it for liquid as well as the gases. So that is the reason why these hydraulic power systems and pneumatic power systems, they have been together, they have been placed in fluid power systems and the fluid power engineering. Now my dear friends, in this the module 4, the pneumatic power systems and the basics of the pneumatic power systems and its advantages, disadvantages and its applications will be concentrated more in the first session. Now if we go through the course objectives, so after going through this the fourth module, students will be able to appreciate the fundamental theoretical concepts of the pneumatic systems. Basically, my dear friends, we have seen many pneumatic and hydraulic systems or even the electrical systems, but we will fail to identify and appreciate this beauty of this pneumatic systems or the hydraulic systems or the electrical system. Now, after this module, you will be able to appreciate the beauty of the pneumatic concepts. Students will also be familiar with the common hydraulic and the pneumatic components. As we know, there are a few components which are being common in hydraulic system as well as in the pneumatic systems, where the pumps, actuators, motors and valves, we always say pump is a heart of the system. No, instead of the pump, we may use a compressor over here, but the actuators remains the same thing. The working medium may change. In the hydraulic systems, we use some liquids, whereas in the pneumatic systems, we use some air. But the components which have been common in the hydraulic systems as well as the pneumatic system, that you will be familiar with that, and students will also have a knowledge on the pneumatic systems and their uses and the symbols that have been used. We might have noticed the graphical symbols even on the pump, the compressors. So what is that graphical symbols which represent, that you will come to know. Okay, students will also gain familiarity with the actual components used in industrial and automobile applications. Why I am talking about both industrial and automobile applications means, it is only one example I would like to tell you. If you go for any industrial applications, for example, if you go for BEML, Bharat Earthmovers Limited, whereas they manufacture the coaches, the train coaches. In order to lift the train coaches, once it has been manufactured, once it has been finished, it has to be lifted and keep it on the railway track, on the track to rail it. Is it clear? So you have to lift it using hydraulic things. So similarly, there are some pneumatic, even in the train horns, they use a pneumatic horns. When you go for the buses, nowadays you will find out automatic opening and closing of the doors. There are the horns wherein which they use a pneumatic one. Even in the industrial applications, for example, a blowing, they use a pneumatic blowers. So different. At the end of this module, students will appreciate and get the familiarity with the pneumatic things. Now, if you come to the course outcome, at the end of the module, students will be able to identify and analyze, that is the course outcome 1, identify and analyze the functional requirement of the fluid power transmission system for a given particular applications. That means based on the application, based on the area of the applications, based on the required field of applications, they will be able to identify which fluid or which method is suitable for that. When you come to the course outcome 2, they will visualize how this pneumatic circuit will work to accomplish the function. So these are the course objectives as well the course outcomes of this pneumatic power system, that is the fourth module. So the syllabus as per the university, it comprises the pneumatic power systems introduction. In that, introduction to pneumatic systems, pneumatic power systems, its advantages, limitations, applications and choice of the working medium, and what are the characteristics of a compressed air, and why we have to study the characteristics of these compressed air is also an important one. And then the air compressors, then structure of pneumatic control system, fluid conditioners, what is the use of a fluid conditioner, what is the significance of using this fluid conditioners, and then the dryers and FRL unit. The FRL unit, which stands for the filter, regulator and the lubricating, we all these three is been termed as an FRL unit. I'll go in detail when I talk about this FRL unit, why they have been always placed all together like a friends. They are all, whether it may be filter or a regulator or a lubricator, we always take it as the friends with the three hands. Okay, it is only I'll explain when I go in detail with that FRL unit. And then in the second chapter of this same module, we'll have an actuator. Apart from this hydraulic actuators, even this pneumatic actuators are also, I always say actuators are like hands of a human being, or like a hands of a hydraulic systems or a pneumatic system. It is only because whatever you think or whatever our heart does, actually the work is being done by the hands. So I always say the actuators are nothing but the hands of a power system, that is, it may be a hydraulic or a pneumatic. Now here also we will be concentrating more on this linear type of cylinders, wherein which the types of linear types of cylinders, there are different types, and working principles of these linear cylinders we will be discussing. And then end position cushioning. This is a wonderful concept actually, the cushioning in the pistons. I am sure that you will appreciate this cushioning effects concept. And then we will be talking about the seals. Seals are equally important. And then it is something like seals are the one. They are like watching dogs. They always takes care about the pressure and all those different functions. I just shall go in detail when I talk about the different functions or the importance of the seals. Most of the people, they will not be aware of it, sealings, because they are all very minute things, but it makes a major difference to the performance and the characteristics of any hydraulic or the pneumatic systems. Okay, then we will be talking about the mounting arrangements. The mounting arrangements, say for example, if you have a FRL unit, which one has to come first, which one has to come second, why it has to be there in the first, why it has to come after this. So those things will come into the picture when we talk about the mounting arrangements. Then we will talk about the applications of these actuators. Then apart from these linear cylinders, we will be also talking about 2 or 3 rotary cylinders and their types, construction and applications. And in the end of this second chapter, we will be talking more on the symbols. That it may be a graphical representation or the symbol they use it to denote it. It is why they majorly go for the symbols. It is only because if I want to show this is a cylinder, so and so linear type of single acting cylinders, I cannot picture it because we are not talking about any biology. I cannot draw the colorful figure of a cylinder and I say this is the so and so type of a cylinder. So what I will do it is, in order to identify, and the meanwhile I want to identify and I want to give an information, maybe for a customer or maybe an operator, okay, or maybe a reader. I want to show them what is the type of a cylinder or what is the type of the system it is. What I will do it is, I will represent it in a symbolic way by representing it in a graphical method. In a graphical representation or the symbols, I will be concentrating. I will give you a set of, at the end of the second chapter, I will give you a table wherein which we will have different types of graphical symbols and their corresponding importance. Now, if you go to the table of contents, this is how I have made my presentation with this. I will be talking about introduction to the pneumatic systems, advantages, disadvantages and applications of pneumatic systems, components, different components of a pneumatic systems and their importance in the pneumatic systems, and then compressed air. Even in the compressed air, we will be talking about why we are using air, why not the other fluid, right? Why we are using it as a compressed air, what are the characteristics it should have an air, and then what is an air dryer, what is a dryer or what is an air dryer, why the air dryer is important, what is the function of this air dryer, what is the role of air dryer in the pneumatic systems, how important it is, that we will also discuss. Then the fluid conditioning. What do you mean by conditioning? Then what do you mean by fluid conditioning? So obviously, so it is all, we are using a conditioner, so that is a fluid condition. We are just conditioning the fluid which we are using it in the system. That's it. And then the FRL unit, my dear friends, as I have always told you, FRL unit is like a three friends who plays a role. Okay, it's like a movie with the three heroes, right? Then we will go to the actuators and then the seals. Few of the keywords that you have to concentrate more is on pneumatics, actuators, compressed air, dryers and conditioners. So these are the keywords which we need to concentrate more. Now let me go through this the pneumatic systems. It is only, my dear friends, certain occasions. I'll give you a small example. You have a rock or a stone which may be of 100 grams. You keep around 100 kgs of load onto that. Obviously, certainly it will break or it may lead to some cracks. The same rock may be of 100 grams. I'll keep it under the depth of a sea. Now, practically speaking, if you take the height of the water which is above this stone, what happens? Does it breaks? Does it cracks? Certainly, is it taking a load or not? Yes or no? It is taking the load, but still it doesn't undergo any sort of cracks or a breaking systems. Why? It is only because the beauty of the fluid which is up with the load which is being forces which will be applying onto this stone irrespective of the geometrical irregularities. That is the beauty of this fluid systems. Whether I'm talking whether it is maybe a hydraulic system or it may be a pneumatic systems. The beauty of this fluid power systems is a one wherein which the force will be distributed uniformly. That is what our Pascal's law states. My dear friends, Pascal's law, it obeys both for hydraulics as well as for the pneumatic system. What does it say? The Pascal's law states that in a confined liquid, it's a confined liquid. In other words, I always say it is the fluid which is under concentration. You take a water bottle and close it. A confined liquid, when the force is been applied, the force will be distributed uniformly, undiminished. The force which has been exerted on a confined fluid will be distributed equally, uniformly, undiminished. That means if you are applying 10 newtons, all the corners of the fluid, the area, the solid area which is in touch with the fluid will experience the same 10 newtons. If you have applied, the same 10 newtons will be distributed. That is what we call it as the undiminished. There is no decay, there is no diminishing of the forces. If you apply 10 newtons, so at the end it comes at the bottom of the bottle, it will reduce it to 9 newtons. No, no, no. What I am talking it is, whenever you apply a load on a confined liquid, the surfaces which is perpendicular to the direction of the force of action will experience the same load which is equally and undiminished. This is what our Pascal's law states. Now, I always exercise one small experiment in my class where I take 1 liter of the water bottle. I just fill it completely. I fill it completely and I will squeeze it. Now you can see the circumferences where you can see the bottles are getting shrink. Now once you apply the load onto the top, from the bottom to the top, whatever the surfaces which has gone inside will come out immediately. That means it shows that the fluid has acted equally from the top to the bottom of the bottle. That is the beauty of this Pascal's law. My dear friends, you just imagine we have no idea how we have been dependent on this, whether it may be hydraulic or pneumatic systems. Starting from a JCB, I'm very fond of this JCB. I always call it as a robot because the flexibility with which it operates. Now you just imagine the days what we have to do it without JCB. Without hydraulic systems industries, it is not possible, because we are not in the time of where the people have built this mummies, that is pyramids, where there were no JCBs and all those hydraulic or pneumatic systems. Nowadays, you cannot imagine any construction, huge construction, or it may be an automobile, or it may be an industrial applications where we are without any hydraulic or pneumatic systems. So now, my dear friends, when it comes to the pneumatic systems, basically a pneuma is a word which has been taken from the Greek. What does it mean? It means the breath of life. The breath of the life. The pneuma stands for the breath of the life, so it is nothing but an air. The breath of the life is nothing but an air. So that is how this pneumatics has come into the picture. Likewise, even in the hydraulics, hydro means water, isn't it? So similarly, so pneuma is the one word which has been taken from the Greek, which stands for the breath. Is it clear, madam? Now, this pneumatic systems is pneumatics is a branch of engineering that makes use of a pressurized gas or an air. I'll come to that later on, why we are taking air in the pneumatic system rather than the gases. That I shall come to that later. In general words, pneumatics is a branch of engineering which deals or which studies the pressurized gas or an air to affect the mechanical motion based on the working principles of fluid dynamics and pressure. Basically, what does it fluid power means? Fluid power is a one wherein which we use a mechanical energy to convert the fluid power. From the fluid power, once again we are extracting mechanical. From the mechanical energy to the fluid power, and then fluid power to the mechanical power. So that is what the fluid power systems is all about. The field of pneumatics has changed from small handheld devices to large machines that serve different functions. Even from the normal punches, from the horn and automatic opening and closing of the doors to the lifting of the trees, it can be some buses or whatever it may be, from cranes or JCBs, anything. From handheld devices to the major robust functions is being dependent on these fluid power systems, or maybe hydraulics as well as the pneumatic systems. Pneumatic systems are commonly powered by compressed air or inert gases. The most of the cases, 99% of the times, we always go for the air as a working medium, and this air we just take it and compress it. And even, my dear friends, I will tell you, from a bicycle to the car or anywhere, if you want to inflate the tubes, obviously we have to go for the pneumatic systems or compressed air systems. Is it clear? So the most industrial pneumatic applications use a pressure of about 550 to 690 kilopascals. That is the maximum of 690 kilopascals. They go up to that. Based on, as I have already told you, based upon the different area of applications or the requirements. Is it clear? Now, people even ask, when hydraulic systems are so sophisticated and they are taking more load, then why do you want to go for the pneumatic systems? There are hundreds of reasons why should we have to go for pneumatic systems, out of which one small example is, if you want to break a stone, you need a hammer. The same way, when you want a small chocolate to be broken, it has to break, then we don't go for a hammers. Is it not? So the likewise, hydraulics has got its own limitations and its own applications. Likewise, the pneumatic has got its own advantages and limitations. So both are important and both have got a different field of applications. And in most of the cases, in few of the cases actually, they use both hydraulics as well as pneumatic systems also. Maybe at the end of this second chapter, I will conclude with that different areas wherein which we use more both hydraulic as well as pneumatic systems. Okay, in other words, pneumatic systems can be simply defined as the effective use of compressed air to do the specific work. Specific work, maybe you have observed many times, if a new road, they are putting a new road with the tar and all those things. Before they put the tar, what they do it, they clean the road, because the dust and the small sand has to be removed, or else there will not be a good adhesive strength for that. So earlier days they used to clean it like a sweeping. Nowadays, what they do it is, they use a compressed air. They use a pneumatic systems or a compressed air in order to clean the road before they put the tar. Patch of works, maybe you might have seen it with the patching works, all those things, they use it. So based on the specific work, they use this pneumatics. Pneumatics is the one wherein which we use a compressed air or a pressurized air or a air with a higher pressure. Air with a higher pressure. Normally, atmospheric pressure is 101.325 kilopascals. So, more than that, a high pressurized air which is being used to do a specified task. This technology or this system, what we call it as a pneumatic system, in a simple words. The compressed air is controlled using a series of pipes and valves. Valves are something like our nerving systems, my dear friends. It always controls. Okay, if you got a pain over here, obviously the fluid or the blood flows more rapidly. So the valves are something like that which work like that. Okay, compressed air is controlled using a series of pipes and valves, complicated systems with mind-blowing capabilities which can be created. Okay, as pumps are treated as the heart of the hydraulic system, the valves in pneumatic systems are considered as the brain of the systems. This is what the beauty is. When we talk about the hydraulic systems, we always say pump is the heart of the hydraulic system. Without this heart, the hydraulic system doesn't work, because the pump is the one which changes the pressure of the fluid or the liquid, which is oil, or which has been doing the work in the hydraulic system. Likewise, the valves are called as the brain of the system in the pneumatic power systems. The compressor, basically, compressors, some different types, you might have seen it. One common compressor that you might have seen it is inflating the tires. If you go for any garage systems, there they will have a green color or some black color, a dome like structure, a boiler like structure, a tanker. Okay, wherein which it sucks an air from the atmosphere. Obviously, from when it is sucking the air from the atmosphere, there will be a filter that we will discuss when we talk about the different components of the pneumatic systems. And then it stores it in a high pressure tank called as a receiver. A receiver is a mandatory wherein which it will be storing the compressed air. Whenever there is a more requirement, it will be used. Whenever there is a less requirement, it will be stored, and further it can be uh, collected with the compressor. This is how it just carries off. So compressor is the one which sucks the air from the atmosphere and it increases its pressure, and then it pressurized air will be sent to the receiver, where a receiver function is the one thing where it takes from the compressor, yes, give me some pressurized air, and it will store it with it, and whenever it wants it, the other people wants it, it just gives it to them. This compressed air is then supplied to the system through a series of pipes and valves. Obviously, whenever it just wants, it just supplies to the system. Then what are the advantages of this pneumatic systems? I'm not concentrating. It is the only advantages compared to the rest of the things. No, the basic advantages of the pneumatic systems are it is more effective. It is more effective. It has got a high durability and reliability, and it is a very simple design. It is high adaptability to harsh environment. Obviously, it can work in any harsh environments. Safety aspects, easy selection of speed and pressure, environmental friendly and economical. Okay. Now it is a very highly effective. That means, as I have already told you, it is a sophisticated system wherein which it affects the work very quickly. The speed can also be controlled, and the work within its limits. Why I am talking about within its limits is, as we have already discussed, the maximum limits will also be there. Within its limits, it works more effectively and it is more durable. That means, based on the field of applications, it can be used for different applications. It is not set, or it is not meant to work in a particular environment or any particular area of applications. Say for example, once if you are using it to inflate the tubes, the same one you can also use it for a spray guns, where they use it for the paintings. So different applications, that durability will also be there, and reliability, you can rely on this completely, because they have got a good accuracy also, and it is a very simple design. Now, why I am taking it as a simple design? Sir, is it a simple design? In compared to what? So, in comparison with a hydraulic system, what I am talking it is, when you go for a hydraulic system, you need to have a tank. You need to have a source. Whereas here, the air is freely available in nature. You can take it anytime. The any corner of the earth you will go, you'll get the air. So no need for the oil to be stored, the oil to be cleaned properly, and oil to be replaced once in often. So that thing will not be there. So it is a simple design. So that is one of the major drawback, where the pneumatic systems can also be used in is used in mobile systems also. In the mobile systems also, it is being used effectively. It is only because of this, because of its simple design. Whenever I say it is simple design, obviously the next point will be an economical one. Obviously, the air is free of cost, no need to pay for that. Whereas if you are using any oil in a hydraulic systems, you need to pay more. Whereas it is a free of cost. So that is why whenever it is a simple design, it is economical as well. The high adaptability and to harsh environment, whether you use it in a nuclear sector, nuclear power plants, or you use it in a monotonous work, anywhere, any harsh environments, extremities, maybe an extreme cold season or extreme hot conditions, maybe a surrounding temperature maybe 50 degrees centigrade, or maybe surrounding temperature maybe 0 degrees temperature, where human feel very harsh environment, even these pneumatic systems can work effectively. Is that clear? But what happens, I do agree there will be moisture content, but we are using a conditioners over here, my dear friends. When we use a hydraulic systems, hydraulic oils certainly affect its properties of will be affected due to the surrounding or extremity conditions, whereas here it is not much. Safety aspects is more, because it is not a combustible one, it's just an air, and it is not combustible. There is no petroleum based oils or petroleum based gases, and nothing is there, so it is just an air. So safety aspects are more, it is not hazardous, obviously. That is what we call it as easy selection of speed and pressure. We can select the pressure and speed very easily. That is why in most of in few of the robotic applications also they go for this pneumatic systems. Then environmental friendly, obviously my dear friends, we are not polluting at all. So we are not burning anything, we are not giving any waste to the atmosphere. So it is obviously an environmental friendly. These are all the few advantages of the pneumatic systems. Obviously, it will also have some limitations or disadvantages of limited disadvantages. It is only because the relatively low accuracy compared to the electric, wherein which they will calculate the accuracy even in the milliseconds, wherein which this pneumatic systems is small relatively. I am not talking about it is a low accurate, it is also accurate, but relatively it is low accurate. Don't get confused, it is only because it is accurate but not highly accurate, it is relatively a bit low accurate. And low loading, obviously it is well known because it is a common sense. When you say a liquid, you consider a water or you consider an air. Air has got a density of 1.12 kgs per meter cube, whereas if you take a water which is of 1000 kgs per meter cube, obviously if you take a liquid, if you take any petroleum based oils or any oil which has been used in a hydraulic system, which will be having a more density than that, that means it will have a more capacity to withstand the load. So obviously the hydraulic systems has got a more load carrying capacity and load pressure generating capacity when compared to the pneumatic systems. Obviously the pneumatic system is certainly have low loading conditions. So that is why its limitations has got its own area of applications. Is it clear? So the processing required before use, it is obviously because even in our IC engines also, whatever the air that we are taking it from the atmosphere, we always filter it. We filter it very finely so that it should not affect the combustion in the IC engines. Correct? So the same air, it is also used in a open type turbines also. We don't take it certainly directly. We have to condition it. We have to filter it properly. So obviously even in the pneumatic system, whether it may be open turbine or it may be in IC engines or it may be in pneumatic systems, when you are using an air from the atmospheric as it is in the nature, so we have to require to process it. We have to process it before using it in the pneumatic systems. Then uneven moving speeds. Uneven moving speeds, rarely we come across it. It is not on a regular basis. Uneven moving speeds in a rare conditions. And noise. It is noisy. It is only because we are using the air. Air always just makes more noise. That is one major disadvantage or drawback of this pneumatic systems. Now, applications, different field of applications of the pneumatic systems is the air compressors, the vacuum pumps, the compressed air. Vacuum pumps, you know it, you just create the vacuums. Okay, then the air compressors we use, as I have already told you. Compressed air engines and vehicles, we use it in vehicles also. Conveyor systems in pharmaceutical industries. Conveyor systems, you must conveyor systems not only in pharmaceutical industries, even in beverages, or it may be even in biscuit factories also we use conveyors. They use it in many industrial applications. In particularly in the pharmaceutical applications, they go for this pneumatic applications. And even these applications are also depends in certain industries where if you go for a CFTRI, Central Food Research Institute, which is there in Mysore, where it is a food-based industry where they cannot go for a hydraulic systems majorly because the leakage of oil may get mixed with the food. So such kind of things, that area of applications may not be suitable for hydraulic systems, whereas the pneumatic systems are more preferred because even there, if there is a small leakages of the air, doesn't causes any polluting of the food. Is it clear? So that is why I have given the next point, which is in food industries. Pressure sensors, switch and pumps, and precision drills used by the dentists. Maybe dentists they use this precision drills, which is of a very minute, small nozzle drills will be there. They also used this pneumatic systems. Then the air brakes used by the buses, trucks, and trains. They know this has been common. The air brakes that has been, even if you see it in the buses, especially in the buses, they will be given it as it's a air brake system is placed in the vehicle. So these are all the introduction to the pneumatic systems, advantages, disadvantages, and different applications of the pneumatic systems. So a few questions I have got over here. In pneumatic systems, the medium used is, it may be an air, or a liquid, or a hydrogen, or an argon gas. It is obviously an air. Okay, liquid is which has not been used. Okay, pneumatic systems is suitable for which or what type of a pressure operation? Is it suitable for a high pressure, or a low pressure, or a medium pressure? High pressure it is for the hydraulic systems. Is it clear? So medium pressure it is for the electric as well as both hydraulic and electric, whereas the low pressure systems always prefer pneumatic systems. Okay. Now, which of the following is false regarding the characteristics of the pneumatic system? It uses air as a working medium. Is it a false? No, it is correct. It is an open system. It is an open system means, why it is open system, not open closed system means, if you take a hydraulic system, it takes oil from the source and it gives back the oil back to the source, that is to the tank. Whereas in the pneumatic system, sort of, it takes from the atmosphere and it leaves to the atmosphere. So it is an open system. It is true. Then it is suitable for high pressure applications. No, we just told you here it is not suitable for high pressure. So C is not, and it cannot be provide high volume pressurized air on demand. No, it can produce. Okay. Which classification of the pneumatics is also known as fluidics? It is a low pressure. Obviously, from straight away we can say it is a low pressure. Pneumatics, normal pressure pneumatics, high pressure, no, it is a low pressure. Which of the following is true for the pneumatic system compared to the cost of the hydraulic systems? More expensive to purchase, less expensive to purchase, cost is same, cost is not equal. Obviously, my dear friend, when I was talking about the design or the advantages, I told you it is a simple design and no need to pay anything for the air. Then obviously our common sense says it is a less expensive to purchase than the other. Is it correct? Okay. Now, so in the next session we will be talking about the characteristics of the air.